So I'm going to do an example for you. This will take 2 pages just because I had to put the graph on the second page or the second video. So example, find the center, vertices, asymptotes, and foci of the hyperbola and graph it. And it's y squared minus 9x squared plus 6y plus 72x minus 44 equals 0. How can I tell this is a hyperbola? Well, if you look at the leading terms, y squared and x squared, they're opposite signs. So that's going to be a hyperbola. There's a positive 1 coefficient for the y squared and a negative 9 coefficient for the x squared. Okay, so that's going to be a hyperbola. Of course, when you complete the square on these, you'll just end up with the equation of a hyperbola. So I just put the y terms together, y squared plus 6y, and the x terms together, negative 9x squared plus 72x, and then I moved the minus 44 to the right-hand side of the equation to just kind of get it out of the way. So that becomes equals 144. Then I have, for the y's, my b is 3. That's 1/2 the coefficient of y. And I write that down. And then I write down b squared, which is 9. And then I can add 9 to both sides of the equation. Plus 9 plus 9. And then that. Now, for some reason, I didn't do the x's at the same time. Oh, because I have to factor the leading coefficient of the x squared isn't 1, so I have to factor the minus 9 out for that one first. So I completed the square for the y squared, for the y's. I got y plus 3, the quantity squared, minus. And then I'm factoring out the negative 9 from the minus 9x squared plus 72x here. Factor out the minus 9. Okay, so what remains inside the parentheses is negative 9x squared over negative 9, which is x squared, and 72x over negative 9, which is minus 8x. Okay, and then I'm going to leave a little space there to add and subtract a number. So I'm just showing where the negative 8 came from. It's 72 over negative 9. And then since I added 9 to the right side, I added that in with the 144 and got 153 on the right. Now I need to complete the square inside the parentheses on the x terms. So for that, my b is negative 4, 1/2 the coefficient here. Then square at 16, so I'm going to add 16 and subtract 16. Why am I adding and subtracting? Because they're inside parentheses and times 9, so you can't just add to both sides. Okay, so I added and subtract 16. The trinomial in front here just becomes a perfect square. It becomes x minus 4, the quantity squared, minus 4 I get from here. Right? So writing this whole thing out, I have x plus 3, the quantity squared, minus 9 times in brackets, x minus 4, the quantity squared, minus 16, and then equals 153. Then I need to distribute the 9 so that I can figure out what the constant on the left is and add it to the right. So I get x plus 3, the quantity squared, minus 9 times, y plus 3, the quantity squared, minus 9 times x minus 4, the quantity squared, plus 144 equals 153. And when you subtract the 144 from both sides, of course, you get 9. Now, this is one place where people can get stuck. What you need to do is, for the standard form for a hyperbola, just like for the ellipse, you need a 1 here. There's no 1 here, so you have to divide all the terms by 9 to make this a 1. That's the thought process, okay? I'm not dividing by 9 because there's a 9 here. That's just a happy coincidence, okay? I'm dividing by 9 because there's a 9 here, and I may need to make that a 1. So I get this. I get y plus 3, the quantity squared, over 9 minus, and then the 9 over 9 will cancel, so I just get minus x minus 4, the quantity squared, over 1. Right? So now the 9, the denominator on the positive term, this one down here, that's a squared. A squared is 9, so a is 3. The thing on the bottom here is b squared, which is 1, and so b is 1. So a is 3 and b is 1 for this one. So I just wrote this with the 9's canceled. A is 3, b is 1. I wrote that down so I remember to use it. So I'll need it. The center is, you set y plus 3 equal to 0, you get y equals negative 3. Y equals negative 3, the second coordinate. Set x minus 4 equal to 0, right? So I did y plus 3 equals 0, I got y equals negative 3. The y coordinate is negative 3. X minus 4 equals 0, you get x equals 4. The x coordinate is 4. That's so you don't get the two coordinates backwards, okay? The vertices, well, the A's are with the y, right? These are the A's, they're with the y term. So you're going to go in the y direction from the center. So you're adding A, which is 3, to the y coordinate and subtracting it to get the vertices. This is just the adding one. I got 4, 0, and then you subtract 1, and you get 4 minus 6. Now you can do this on a graph. Some people find it easier to just do this on the graph. It's just I had to put the graph on the next page, so I did it this way. C squared equals a squared plus b squared. So for hyperbolas, it looks like the Pythagorean theorem. So c equals, what's the positive one? The positive square root. So c equals the square root of 10. So the foci, you have to add and subtract 10, square root of 10 from the second coordinate. So then the asymptotes, y minus k equals plus or minus a over b, x minus h, that's the general formula. Then I just plugged in the numbers. K was negative 1, so y minus a negative, k was negative 3, so y minus a negative 3 equals y plus 3, right? So you get y plus 3 equals plus or minus 3 times, because a is 3 and b is 1, so 3 over 1 is 3. 3 times the quantity x minus 4. That's the asymptotes. And so then I'm going to list those main properties on the next page and then graph it.